And we are live. Good evening, everyone. Welcome back. I hope you guys enjoyed the first week of August. It was pleasant. It was nice. Now, things are starting to get pretty interesting around here. We're going to talk about the thunderstorms first, and then we'll go into Erin and also discuss the weather pattern that is evolving. As always, just so you know, we go over the forecast first, and we answer all the questions in the premium chat room, and then we go check out to see what's floating around social media on YouTube and X. So if you have any questions, I pick the best ones and dive into there. So let's talk about the rainfall first because that's what everyone's asking. I did promise I would start with that first. And currently, right now, we have showers and thunderstorms that are moving through the region, some very heavy rainfall. This rainfall is driven by an impressive axis here in precipitable water value. Now, for those of you who don't know, precipitable water value is a measure of moisture in the atmosphere. And what we typically see is when you have an axis, which typically aligns around the I-95 corridor because of the enhancement of the urban heat island effect, you end up with some very impressive heavy rainfall. And we certainly had that in Freehold, and we're dealing with that in Long Island right now. These showers and thunderstorms really didn't feature much in the way of severe weather. We had some downburst wind gusts, and around Newark, they reported wind gusts around 55 miles per hour. So we had a few isolated severe thunderstorms. But the interesting thing with this prefrontal trough is that the cutoff to the rainfall is pretty quick. So I would say that the Bronx, you're pretty much over. Give it another 15 minutes around City Field, and then you should start to come into an end too. I would say about 8:45, 9 p.m. You'll probably see a start time for both games. In fact, I think I just saw something like that on SNY just now for a start time around 8:45. This line was driven by the prefrontal trough. Now, a lot of times when you're dealing with thunderstorms, you typically deal with the cold front being the main primary forcing parameter. However, lately this summer, what we've been seeing is that with the cold front well off to the west, is the prefrontal trough, which is basically a divider in terms of the amount of moisture in the atmosphere that has triggered the most thunderstorms with our frontal passages. And you can see on the water vapor satellite projection here, let's just jump to the 250 millibar winds. You can see your primary polar trough is still way back to the west with our cold front. And that's typical for the summer. What's starting to change is that these troughs are getting deeper and deeper, which is typical for this time of year. I mean, after all, we are heading towards fall. When we start to see this evolution take place, what typically occurs is that these cold fronts get a little bit stronger and the prefrontal troughs become less of a factor. But we're not there yet, but we're moving in that direction. So that's why we're seeing our showers and thunderstorms. Tomorrow's cold front will feature showers and thunderstorms, but it'll be more isolated in coverage. It won't be as strong because you're not dealing with as much moisture. This deep moisture that you're seeing right here will be pushed off the coast. We'll still have this amount of moisture, around 1.5 to 1.9 inches, that can support a few thunderstorms capable of heavier downpours. But the strong lifting that is associated with this cold front, which let's take a look at some of the model guidance here. So you see this feature right here? This is enhancing the prefrontal trough, right? So this little short wave here in the jet stream. The cold front is still back here. So the support isn't as strong. So what this all translates to is that if you have this type of strong lifting, and you can also see that pretty nicely here on the water vapor satellite picture. Let's refresh this real fast and see. There is our lifting. So again, you can see the strongest lifting here. Your cold front and your trough is back here. Notice the substance here. And as a result, once this blows through, showers and thunderstorms cut off really, really fast. So heavy downpours, and then we clear out. So I do expect us to see baseball this evening. I was asked that before starting. Hey, when are we going to experience that? So this is all clearing out. Tomorrow, I don't expect much in the way of severe weather, aside from maybe an isolated downburst wind gust. That's pretty much about it. And for tomorrow, the coverage for those thunderstorms will be isolated. But for this evening, the showers and thunderstorms will continue to drop south. Let's zoom out a little bit. And we still have much of southern New Jersey dealing with some moderate to heavy rainfall. This will continue to sink south through the overnight period. We're going to lose our severe threat, which was marginal to begin with, but it's pretty much going to be gone. And the reason why is because we're losing our instability. Let me show you a couple of indices. Bulk wind shear is very weak, almost non-existent. And our instability, we'll take a look at the CAPE values. And they're up there at around 1,500 to 2,500 joules per kilogram. But you see all this blue shading here? That's kind of like your cap, okay? So the darker the color, the stronger the cap. The stronger the cap, the harder it is you're going to get severe thunderstorms or thunderstorms in general. So this is more of an elevated environment. And you can also see that pretty nicely here on your lifting index too. The same type of environment that once you lift the cap, then you can end up with some stronger thunderstorms. We're going to refresh the HRR. I did this a while ago. Let me go refresh this here and zoom in here to kind of give you another view. Again, here's your stable layer. There's your cap right there. Here's your instability. And then here's all your saturated environment supporting generally heavy rainfall. So there are slightly elevated thunderstorms, not really much in the way of severe weather. Why not much in the way of severe weather? Well, the winds here are awfully weak here, and you're not going to get much in the way of vertical wind shear out of this, either via speed shear or directional. It just isn't going to happen. So that's why you're pretty much dealing with an environment with heavy downpours, and that's all clearing out. So for those of you asking about the Mets game and the Yankees game, yes, they'll play. They'll play late tonight, 8:45 to 9 p.m. You should see a start time, and away you go. Now, for what everyone's been else has been wondering, what about Erin? Very interesting storm. You know, the thing with Erin that I find interesting, and it's a small storm, and small storms can create a lot of havoc on two fronts. One, the rate of intensification, and two, the ability to alter the 500 millibar pattern. And today we saw a potential outcome of what that might look like. So let me take a look. Let me first show you the satellite picture. Let me pull that up first. And go. Okay, here's Erin. Couple of things to notice. First and foremost, deep, very cold convection starting to pop right over the low level center. For the past couple of days, this storm's been battling a lot of dry air, a lot of dry air. And I told, all the premium members, and I've been telling you guys, I said, hey, look, if we're going to get a lot of tropical systems, they're going to have to overcome a lot of this dry air that's sitting in the Central Pacific and Central Atlantic, which is why I was against going with an above normal season. I stayed average because the National Hurricane Center likes to jump the gun on subtropical lows. So if they're going to count that, most likely they're going to end up with at least near average. But a very active Cape Verde season, I don't see, because it's dealing with a lot of this dry air that's inhibiting a lot of these short tropical waves. But this one broke through. And up until about this morning, it was having a difficult time sustaining convection around the low level center. Now it's finally doing that. You're seeing this kind of percolating type signature here showing up here. Very nice developing, starting to form a nice little central dense overcast, starting to set up deep convection around the low level center. That's all cute, okay? And I'm sure there are a lot of people focus on that, but that's not what to focus on, ladies and gentlemen. What's interesting is that right there. Here, let me pull up the pen here and let me see if I can circle it. See that right there? And you see this up here? That is what I am interested in. Why? When you have an engine, okay, you want to have an engine that has a good outflow, a good way to expel the energy it's using. So a warm core low uses tropical moisture from the ocean, lifts it, it condenses, and then it expels out. If you have an engine that's choked off, it can't organize and intensify quickly. But If you have one with a well-developed structure already, well, things could get interesting then. And that is exactly what we're seeing here. A nice, healthy, anticyclonic circulation developing in the upper levels. The moisture is being lifted, the thunderstorms are becoming stronger, and then the byproduct of the latent heat release is able to expel out. So when the latent heat expels out, it allows the storm to further intensify. And that is why we're starting to see these cold cloud tops starting to develop, because the warm core circulation, the vertical warm core circulation, is maturing. Now, when you have this type of setup, it does two things. One, it supports rapid intensification. Two, it allows for mass buildup on either side of the tropical system. And this is where you have a situation where it can really build up the Western Atlantic Ridge. And this is where things get a bit tricky here. So when we take a look at the models here, and let's see here, we'll start off first with the European precipitable water. And the reason why I want to show you this is that when we see this, and this is, let's just go out to 90 hours out from the 12Z guidance. What does this show me? Well, it shows me a deep concentration of very, very impressive lifting of tropical moisture. So this is a healthy storm here. More importantly, look at the outflow. Look how well established that is. And look at the convergence and confluence that's showing up here in that moisture. Mass is converging to the north of it. So what that leads to is rising heights. So again, here is the European look of it. And see this 540 here? Watch how this grows. This is how it gets as far west as it does. Now, is this correct? Well, we know that the GFS is a different look here. It doesn't build the ridge as much. It still creates a strong storm, but it doesn't pump up the ridge because the ridge is a little bit displaced more to the northeast of the circulation rather than the north. So it builds up heights out here, but it leaves open a wider door to get picked up by this trough. So what are the features that are agreed upon? Both models suggest there's going to be below normal heights around the Canadian Maritimes and over New England, which will support a trough to extend down into the coastal plain here of the Mid-Atlantic. So that type of scenario with this positive tilted trough is showing up on both guidance. Let's see here on the European and here on the GFS. Same type of signal. Slightly different orientation in terms of the width and the depth of the trough, but it's the same idea. So where we stand right now with this storm and the questions that we're still going to have that we have to monitor and we'll likely be talking about through the rest of this week with the premium public video and into early next week. How does a storm pump up the Western Atlantic Ridge? And what is the interaction? What is the timing of the interaction of this trough here? Now, one of the things that is very good news for us to keep this storm away from us is notice the orientation here of this trough on the GFS and this trough on the European. They're both positively tilted. Why is that important? Positively tilted troughs means a southwesterly flow, which means whether this storm is able to get towards the coastal waters or remains out towards Bermuda, it's not going to be able to make landfall because the steering current on all guidance suggests that it's going to be kicked out. Okay, so you have that southwesterly flow in place on all guidance, and of course, when we take a look at the average model guidance here, a lot of the models, good portion of them, suggested turn north pretty quickly. On the European ensembles, a good portion. Again, same theme here. They all pretty much keep them out over the coastal waters. I do not expect at this time a landfall at this time. But I do expect it to get close enough to create some strong riptides. And I would say if you're on the Jersey Shore or on Long Island, I would not be surprised if we see some minor to moderate coastal flooding as a result of this storm via the strong wave heights. I do expect it to strengthen into a major hurricane because the structure of this storm is such that everything's there to allow it to mature. It's small, it's compact, it has a good engine, good outflow, good development of convection. I expect rapid intensification of this storm. But because all guidance right now is suggesting a positively tilted trough approaching the East Coast, no matter how strong the Western Atlantic ridge gets, that storm's going to take a turn north and then northeast away from us. The only question now, to me, is just how close does it get to the coastal waters before it makes that turn north. So the areas I would say that I would be very mindful of and keeping an eye on this would be the Outer Banks of North Carolina, possibly getting clipped by this. And then, of course, if you're on the immediate coast in the northern mid Atlantic, I would say riptides and coastal flooding would be a concern. But the only way I see this coming in and impacting the coast is one of two things. First of all, this Western Atlantic ridge is over 594 decameters, which would then really, that would tell me that this thing's up to like a category 5 and it really pumps up this ridge. Because remember, if you're having an intense falling ice here, there has to be a balance. So that balance would be the building of this ridge. Don't see that happening yet, but that would be one factor. The other factor is this trough is delayed, or we end up with more below normal heights down here in the Tennessee River Valley. Right now, I don't see any indication of that happening at all in any way, shape, or form. So I kind of like where I'm standing right now, where I've been standing. The good news is that yes, we're seeing some shifts in the model guidance, but nothing that changes the fundamental structure that we just talked about with this pattern. There is no model guidance that is suggesting an upper level low in the Tennessee River Valley, a neutral tilted trough or a negatively tilted trough, which then would be big trouble for us, or any type of indication of the storm being able to track straight into the coast or anything of that nature. There is no guidance to support that. So that's certainly some good news in that respect. But certainly this storm is going to be one that it's going to be pretty impressive. And then after this storm, let me pull up the rest of the Atlantic. We have a little wave here around the Yucatan Peninsula. Maybe 10% chance around the Bay of Campeche could develop this weekend. But that's going to go into Mexico. I don't expect it to be an issue. It only has a 20% chance of forming. And I think that might be generous. So we'll watch that. We'll see what happens to that. The next one is way out here. Let me just drop this. It's under the CDM signal right here. Let me zoom in. Here we are. Right here. This tropical wave right here. Again, this one's going to have to battle the dry air as well, but there are some indications this one could have a shot at developing as well. I don't see this pattern that's in place right now, especially with the MJO moving out of phases, out of phase 2 and 3 in the next couple of weeks. I don't see any indication of this active period remaining sustained. So, I wouldn't let your guard down, but when I look at the SOI here, I don't see any type of strong La Nina signal. The MJO signal here, again, we go through phase 2 and 3, which would support an active period, which we're in. But notice towards the end of the month, we go into a neutral state. And when we take a look at the long range European, again, it's in the circle of death, which means that we're losing our support for tropical development for the heart of the hurricane season. So certainly some good news there. I'll take it. I know that there's some people who are like, "Oh, I want to see a hurricane." You're nuts. You do not want to see a hurricane. Anyone who went through Sandy should not say that they want to see a hurricane. And to understand the phases here, so our active phases is typically phase 7, 8, 1. Notice you've seen the increase in the lifting here. Okay, precipitation potential, phase 1, phase 2, phase 3 starts to fall out of it. Phase 4, 5, and 6 have more negative values. So typically, when we're looking for an increase in tropical activity, you start in phase 7, marginal, and then you rock and roll phase 8, 1, 2, start to decline in 3, and then 4 and 5, it's just kind of the death nail. So right now, we're in some interesting phases. When we go into a neutral state, we kind of lose all support and it just collapses. So, and again, we don't really have any type of El Nino or La Nina or anything of that nature. In fact, the current state of Enzo is basically a wash at this point. You have some warm waters in 1+2, some slightly colder waters in 3.4, but certainly not supportive enough for a La Nina or anything of that case. And it's been pretty marginal going back and forth for quite some time. So with our weather pattern, my main focus is what's going on in the stratosphere right now. Tropical forcing is muted and a mess. So that makes things more challenging, which I like because, I like a good challenge. So, what is the primary forcing parameters here? And the primary forcing parameters of what's going on in the stratosphere. I know, it's weird because it's summer, it's warm season, but that's where we've been all summer. And that is a good hint for what we're going to be dealing with in the fall. This signal right here is what I have my eye on because this has been sustained for several months, not weeks, not days, months. We had a little bit of decline in July, but now look at it. It's fired right back up. It looks like a Bunsen burner is under it. It is very, very impressive. The reason why this warming is important is because when you get stratospheric warming here, at the surface and at the tropospheric levels, you end up with below normal heights. Because again, you have to have a balance in the atmosphere, right? So you're having a warm environment, okay, in the stratosphere. The stratosphere cannot expand out into space, so it must expand down into the troposphere. And when you expand down into the troposphere, you depress the heights in the troposphere, which leads to upper level lows and upper level troughs. And in this case, a negative EPO. Now, this isn't changing anytime soon. And the, let's see if I can find, here we are. The QBO is in an easterly phase. I've been talking about this for quite some time with premium members. The easterly phase is very, very important to me. It's a very important signal because when you have a QBO in the easterly phase, you start to build up the support for high latitude blocking, and blocking is slow to decline and dissipate. And what have we been dealing with for quite some time this summer? A sustained negative EPO with an unusual stratospheric influence because the tropics have been muted. A lot of interesting signals showing up here. So I think what this will tell me is that at least through early fall, we should sustain with this easterly trough. And the future of Erin, as it lifts northward, we'll zoom out here, as it lifts northward, it's going to pull down this polar air mass. So the polar air mass that is, make sure if I could draw it right here, uh, right up here is going to get pulled south as Erin lifts northward. Okay, so it's going to kind of act like a dumbbell effect where it's going to swing up, head up towards the Canadian Maritimes, enhance this upper level low here, and drive a fresh polar air mass in. So the weekend, let's say starting after August 22nd, don't be surprised if we end up with well below normal temperatures. I'm going to have to adjust the long range forecast based on that, um, because it's going to be able to tap in to that polar air mass and drag it south as a counterbalance to all that tropical moisture lifting northward towards the Canadian Maritimes. So interesting times, that is for sure, and it could lead to a very, very nice weekend. If you have any plans for the 23rd, 24th, it's looking at like really, really nice. We're talking about temperatures of 70s and 80s, low humidity. Hey, I'll take it. So, very interesting pattern is certainly evolving. Now, let's see what we have here on questions. Definitely looks like we have a lot of questions here. As always, it's good to see everyone. I see Card is very active as usual. Just a quick update: Cincinnati bludgeoning the Phillies 8-0, which I'm keeping an eye on because I think if the Mets win tonight, they're only 4 games out. I think the Mets are coming back, guys. Okay, so as sun angle continues to decline and daylight time lessens, yes, cold air pulls should start to increase substantially at the source areas, I would think. Oh, yeah, absolutely. It's already starting to happen. In fact, let's see if I can pull up some data on that real fast. And let's see, we'll do 850 temperatures. Let's see what that looks like here. There we go. Now again, this is mid-August. You say mid-August, it's August 13th. And look at those cold pools. This is at 850 millibars, developing very, very nicely. Nice little vortex here up towards the Arctic Circle with nice Arctic air starting to build already. So again, nothing that's abnormal or shocking, but yeah, certainly the cold air is definitely starting to build here. That is for sure. Question regarding Erin. If it becomes a major hurricane and stays out to sea and is a strong hurricane or post hurricane in the northern mid Atlantic, will that amplify the polar jet stream further, possibly kicking off at least a temporary pattern change? I think it'll enhance the weather pattern. Um, I the NAO has been trending more and more negative of late. It kind of bounces positive, negative, but the overall theme is more towards negative. I think this will push you more towards the negative side in this type of environment. What does tomorrow mid afternoon look like? Isolated thunderstorms, nothing like what we're seeing tonight. But a few of those thunderstorms up until about 6 p.m. will be capable of a heavy downpour. I don't see severe weather, and again, the coverage is going to be far more isolated. I noticed that while sunspot activity is up recently, yes, it is, very much so, the vast majority are stable. I know the negative QBO is a factor, but even with that, is it surprising that the warming is occurring given we are still in a period of active sun? See, the sun has an impact on the stratosphere, but the sun isn't the only factor on the stratosphere. I think that part of the factors with the volcanoes, I think that is certainly a factor that I am struggling with to try to counter and include into the analysis of the stratosphere, especially with the reducing influence of the water vapor in the stratosphere. The QBO change, that's certainly something that would support this type of stratospheric evolution. But I don't think that the solar influence on the stratosphere is all that strong at this time. It becomes more of a stronger influence as we head towards the cold season because you end up with stronger gradients. With that said, the one thing I would really, really keep an eye on is as we move through the winter, if the stable sunspots that do develop, if they become more and more stable and we don't have as many of the CMEs impacting us and we don't have as many holes, coronal holes, then that would support an environment where you could see active sunspots, but not as much reduction in the ozone, which would then lead to a warmer environment. So these are all factors that we're going to have to consider as we move forward. Are small circulations less susceptible to dry air influence? It seems a bigger wind field storm could suck in more dry air. Small circulations are very volatile. Okay, they can get whacked pretty good by dry air and get torn apart. but they can also rebound. I call them the Rocky storms, okay? Because Rocky generally was on the smaller side boxer, right? You can beat on Rocky and somehow he still gets up. Well, I mean, if it was real, he would be able. He'd probably get thrown out. But you get my point. These small circulations, they can take a beating and struggle, but once they get into a good environment, they blossom very, very quickly. So they can be a real pain in the neck to forecast in terms of intensification rates and what to expect as far as the track and the strength of the storm. But they can also be easily influenced by negative factors as well. So you can have times where it jumps up to a category 3, runs into some dry air, starts to run down before you know it's back down towards a tropical storm, all within a 66-hour period. So they can be a real pain in the neck. Daniel says, I'm Daniel's Veins. I'm very interested in thinking about the upcoming 2025-2026 winter season. Oh, I know everyone is. What has my interest in particular is the warm sea surface temperature anomalies over the Gulf of Alaska and Eastern Pacific, up the positive PDL. I do recall this 2014-15 winter season featuring above normal sea surface temperatures in the Eastern Pacific that supported an established negative EPO and negative Arctic Oscillation NAO. They can. Now, here's the thing. When it comes to long range forecasting, and this is something I had to learn, it took me a while to learn, there is no hard rule. We try to create hard rules. We try to create these, well, if you got this and this, it equals C. No, that's not how the atmosphere works. Yes, there is some interesting similarities to 2014-15. Yes, in terms of the sea surface temperatures. But it's not the same stratospheric environment and possibly not the same gradients. The reason why I don't issue a winter forecast this early is that we have to look at the snow growth. We have to look at the evolution of these sea surface temperatures as we move through the early fall. And also, we have to study how the negative QBO is interacting with mountain torque that will influence your AAM, your atmospheric angular momentum. Once you figure all that stuff out, then you can start playing with things, right? But it is a good observation. It's a fair observation to say, I wonder what's going on here. It's fair, but you don't want to jump the gun just yet. Is there anything that could cause a trough to tilt neutral or negative? I don't see anything that would tilt it negative because what you would need is a stronger block in the northern Atlantic, and I really don't see that happening. That actually could form via Erin later, but not before it. In terms of a neutral trough, thus far, I literally have no data to support that, nor do I have any observations to support that coming in from the Pacific for the trough that will be approaching us by that time period. So at this time, I don't have any data to support that potential, which is why I'm pretty positive with the idea of a positive trough. So basically, the SOI is going to be a trampoline bouncing between positive and negative. Yes, with the MJO phases. It's going to be like a roller coaster. How long is the QBO expected to stay in the easterly phase? Usually, once you get locked into the easterly phase, it lasts through the winter. So if it started getting to easterly phase now, that will continue. That would give you your phase all the way through the winter, and then it starts to gradually change towards next spring. So if we were going in positive, we would pretty much look at positive going through, and negative, pretty much negative. The next thing we have to study is just how strongly negative. As always, too much of a good thing can lead to um, unexpected results. So, are we talking about strongly negative QBO or are we talking about moderately? Typically, your most impressive winters, you're around -8 to -10 um, meters per second. So, I think that's what we're going to be watching out for as we study the QBO moving forward. We were thinking of traveling to Florida. We were wondering, even if it does not make landfall, what impact it will have on the southeastern coast, like precipitation. As it stands right now, like let's say Georgia and Florida, you look like you're pretty good. Okay, as it stands right now, I'd probably feel more confident about that once we get to Friday. because then we have a pretty good idea with the lat long. But the way that all the model guides suggest is setting up, this storm's going to be tracked in such a way that it can't possibly hit Florida unless something fundamentally changes in the whole structure of the atmospheric pattern. So I'm kind of taking Florida out. Georgia, it looks like that's pretty much a miss as well, but certainly some enhanced wave heights. If there's going to be any type of impact, I'm looking at South Carolina and North Carolina, if anything. Okay. And that is pretty much, if I'm going to put it percentage wise, I'd say 10% for the Outer Banks of North Carolina and South Carolina, and then 1% down towards Georgia and Florida, and 1% up towards Virginia, up through New York City. That's where I would put it right now, and that is quickly going to zero once we get more and more data on the evolution of this storm and how it impacts the Western Atlantic Ridge. Hurricane Charlie was a good example of Rocky Hurricane. Yes, absolutely. All right, so that is the premium chat. Let's see what we have here on YouTube. Need more water. My throat's already going. Why do you think New York TV Mets lead their forecast with the heat index as their top line number instead of actual temperatures? Well, they never explain it is not a measurable quantity with numerous assumptions. Well, no, not. I wouldn't call it numerous assumptions. It's a pretty easy equation, actually. You're taking the heat plus the humidity. Why do news stations lead with it? Because when it comes to the news, and remember, this is also a business, it's about what people feel. Emotions matter, okay, especially when you're in TV business, right? So it's not anything where anyone's being misled or anything. When you're talking about a heat index of 101, that's a story about how the heat is impacting your body based on the temperature and the humidity in the atmosphere. Um, so if it feels like 101, that's dangerous. And you need to stay out of those type of conditions as much as possible, especially if you're elderly or if you have any type of health issues. Otherwise, drink plenty of water. But I don't think there's anything nefarious about that at all. Is there a reason why we're seeing stronger lifting with prefrontal troughs than with cold fronts? Is that normal? It's normal during the summer. You see that a lot, especially in the plains and the mid-Atlantic, because you have a lot more moisture boundaries, a lot more mesoscale boundaries, sea breeze fronts and whatnot. Um, doesn't always line up that way, but it makes a lot of sense in the northern mid-Atlantic because your cold fronts are associated more with your polar jet stream, but the polar jet stream isn't as deep, and so a lot of your mesoscale events, because that's what a thunderstorm event is driven more by the moisture gradients, which typically are found with your prefrontal troughs than your cold front. As we get towards the fall, like September and October, your alignment of strong thunderstorms and the actual cold front is going to be far more clearer because we're going to have far more dynamic polar air masses to set up that divide. Let's see here. Let's see, correct me if I'm wrong, but it seems like negatively tilted troughs are more common in the winter and spring than in the summer. Typically, and the reason why is this. Negatively tilted troughs, they can happen in the summer, but the reason why they typically do not is because uh, in order to have a negatively tilted trough, you have to have stronger jet streak on the lee side of the trough, which typically aligns more with what happens in the spring and in the winter and in the fall. So a good example would be Sandy, which happened in the fall. Why? You had an upper level low that developed in the Tennessee River Valley, and that allowed it to pull the storm in towards the coast, essentially a negatively tilted trough. So yes, you typically see more positively tilted troughs in the summer because you typically deal with the very base of the polar trough lifting away from the region. Uh, let's see here. I heard that the solar minimum could affect on earthquakes and volcanoes. Have you heard anything? Well, first of all, we're nowhere near a solar minimum yet. So that wouldn't really, it doesn't jive with where we're at, right? I've heard this, I've seen this floating around. Um, Solar minimum is probably about 3 years out. There's a lot of people that try to connect the solar winds to volcanoes and earthquakes, and then try to talk about the changes in our polarity. Right. I am not an expert in terms of geology, so I don't want to pretend that I am. But the last time I talked to a couple of my friends who are geologists, they are not worried about what's going on with the sun. A lot of people are making a lot of statements based on um, the fact that something happened, let's say an earthquake, when we happen to have a solar flare. But then if you ask them, and I actually had this debate, this is a good way of finding out whether someone actually understands. Ask this person, okay, you're showing that A happened and then B happened. But what is the physical properties that cause the influence from A to B? Like, for example, I can say that because I wore my lucky shirt, the Mets won. But there is no indication that me wearing my lucky shirt is all of a sudden going to have Pete Alonso hitting 3 home runs. Like, he's not going to feel my aura and start hitting home runs, right? So you have to ask yourself, okay, what is a physical property that's going to cause an earthquake, right? And if you can't connect that physical property, all you got is a happenstance that something happened at the same time as another thing happened, right? You wear a red shirt and there's a car accident. Your red shirt didn't cause the car accident, right? So that's why you have to be really careful with that type of stuff. And as of yet, and I'm a nerd, so I'm always looking up for this stuff. I've yet to find any type of peer-reviewed support that sunspots directly caused earthquakes. However, in terms of changing polarities in the Earth, which is a normal process. And of course, you do see an uptick in geological activity. That is normal. I mean, and are we due for more earthquakes and whatnot? Some say yes, some say maybe, but that is something that I am not versed in strongly. But I do know that earthquakes are a normal thing. Sometimes it has nothing to do with causing, and we're going to find things out. It's the earth, and sometimes bad things happen. What influences thunderstorm lightning frequency? Oh, that's a good one. The more moisture you have in the atmosphere, the more likely you see frequent lightning. So when you have high precipitable water values pushing over 2 inches, expect frequent lightning. Fundamental correlation does not imply causation. Yes, that's exactly what I'm trying to say. There we go. Perfect. Do we have any questions on X? Woo, good deal. All right. And then I'll jump right back to the chat room here for premium members. Didn't realize both the Yankees and Mets are at home. Yeah, but they'll be playing soon. All right, what do we got here? Jeffrey Lamb. Hey, Lamb. How you doing? All right. So if we get a larger typhoon in the Western Pacific that maintains energy past Japan, what does that do to the QBO EPO? No impacts on the QBO, okay, because that's in the stratosphere. What it could do is influence the EPO and intensify it. And typically, when you have a strong typhoon that lifts up towards the northern Pacific and it remains like a category 3 or 4, that can enhance the wavelength in the polar jet stream and cause more dynamic storms. I typically look for some sort of impact like that once we get into September and October, because the polar jet stream has a stronger interaction. We start to see that evolution more. But it has no impact on the QBO. But the EPO influence, yes, it could definitely influence and enhance the trough. Let's see here. So basically, the short waves in the polar jet in the summer reduce the chances of negatively tilted trough. Yes, basically. You typically see a lot of negative tilted troughs once you get past. I usually start looking for them after September 15th, when things can really get interesting. So I think we got a month out. That doesn't mean you can't have one in August. It just becomes more difficult. Let's see here. It seems that over recent decades, a lot of warming in our area is caused by higher nighttime temperatures than daytime temperatures. Is there any reason uh, why to why this happens for our area, part of North America? Okay, all right. This is a good one. You see, Freehold is a great example of this. Anyone who knows Freehold, New Jersey, is in central New Jersey. And I'm going to tell you a little story. When I was a child, I moved to Freehold. And when I moved to Freehold, I was 5 years old. It was 1983. Yes. And at that time, our major concern was not highways. It was not traffic. It wasn't. It wasn't anything like that. It was bulls. Yes, bulls. Bulls were running around. We had corn everywhere. There was no mall. You had a horse. You had a guy on a horse, sometimes going down Route 9, which at one time was one lane, right? It was a simple time. Most most places had cornfields all over the place. And a lot of the roadways were just single roadways. That's it. One direction, one way or the other. Now fast forward to today. Today, we have malls, we have an ever expanding Route 9. We have houses built all over the place. What once had cornfields now have million and $500,000 homes with air conditioners and sidewalks and concrete. And all of that retains heat. So when you have this set up, this type of environment keeps your low temperatures warmer. And so you start off at a higher base. Now your 850 millibar temperatures haven't changed all that much, but because you're starting off at a higher base and you're able to retain that moisture, your low temperatures end up being warmer, and sometimes your high temperatures are near normal, but the overall average is above normal. So that's why you're seeing what you're seeing. Very warm waters in the North Pacific. Can this be a problem in the winter with strong jet torching the country? Well, no. It just depends on where the orientation of the water is and how it interacts with the rest of the weather pattern. Again, you never want to make one-to-one correlations on this stuff. Don't ever try to lock yourself into rules on this stuff because it can end up um, leading down the wrong direction. Let's see here. Assuming Aaron does come west and scrapes North Carolina, that's an outlier. Now remember that it's an outlier, um, and shoots out to sea. Would there be any coastal flooding for New Jersey? I would prepare for at least minor coastal flooding in New Jersey for this, and certainly, I mean, even with an easterly flow, we see minor coastal flooding threats. So I would definitely be prepared for that. If I would also be um, concerned about uh, what was I going to say here? The wave heights and the rip tides as well. How certain are we about Aaron for next week? I am moderately comfortable with where we are with the forecast right now. Again, you have to watch it. With these small storms, there's always a degree of chaos and volatility involved. So again, we'll have to watch that very, very carefully. But the overall 500 millibar pattern in this setup would suggest a storm track off the coast. We'll have to keep on watching it. Again, I'm not saying hey, ignore it, don't worry about it. But as it stands right now, I don't have any data to support any type of major concern or major changes to our thought process right now. We actually need an active tropical Western Pacific and strong storms recurving past Japan for any impact. Past couple of years have been remarkably quiet in the basin, respectively speaking. Yeah, it has been. And we've seen a little bit of an increase in activity. On the opposite end, do you think there's any chance of Aaron bringing rain even further north, New Jersey? Right now, I don't see that. I don't see a direct impact. At what I do see is that the cold front associated with kicking Aaron out to have pretty good thunderstorms out of this. So that's something that we're definitely going to have to watch out for. But I don't see any direct impact as of now from Aaron from moisture. Again, what would I watch for? Okay, if the trough is delayed, that could be something to watch out for. If the Western Atlantic ridge is stronger than what's being modeled by the furthest outlier, that would be a surprise. These are things I would look for if there was going to be a change, right? So as I'm going through the model guidance and looking at the observations and making comparisons, if I see these clues showing up, like, hey, this trough is going to be more delayed than what was originally forecasted, or hey, this is going above 590 decameters as far as the ridge, those would be warning signs. As it stands right now, I got no warning signs. There is no right now. Everything's at a green yellow hue. Okay, there is no red flashing warning signs for a shift well west into the coastal plain. But if you see that delay in the storm, that would lead to a delay in the trough. That would lead to a warning sign. Thus far, I don't see anything being of that threat. Okay, so I think we got all of the questions answered. And the Mets have started playing, and already Pearson's doing a pretty good job, so it's good to see. Uh, huh? Yeah, I got all of them on YouTube. Got all of them knocked out. Look at that. Very active on YouTube too. Thank you guys for joining, especially during the summer. I've seen a lot of activity, and thank you because I really appreciate that. Because I look, I understand it's the summer, and typically a lot of people are not worried about showers or thunderstorms. They're here for the snow. I get it. I get it. I do. Because I'd probably do the same thing when I was like, teenager or in my 20s, but I do appreciate everyone definitely. Yes, we are, and we are doing a good job. We got the whole house decorated. We got we just have to do the outside, but well, Susan's really been the one decorating. I just kind of, huh? That's okay. But look, well, my wife was saying that we're decorating in the house, right? So for Halloween, right? And yes, exactly. Exactly. We're trying to will fall into existence because I am not up with this heat and humidity. I am done with it. This probably is why I'll never move to Florida. I don't know what the hell those people are thinking. Like, oh, it's hot and humid. I'm like, no, thank you. But it looked like we answered all the questions that we were looking for. Just saw that about 500 to 700 feet up the road, there is a good sized power outage with a bunch of buildings out. Oh, that's not good. Well, then again, it is New Jersey. It doesn't take much. This is why we have a generator here, okay? Because it yes, it definitely has paid for itself already. Because I'll tell you this right now, with um, the power outages here in New Jersey, I probably would have lost half my food already if it wasn't for the generator we got in here. The first thing we did when we bought the house was get a generator because I've lived here my whole life. I'm not messing around, so doesn't surprise me one bit. Well, it looks like we covered all of the questions and we had a pretty good live chat. So, thank you again for joining us. We'll keep an eye on what happens with Aaron. Of course, we'll have updates as we move forward. But don't panic. Just be prepared. Like I've been saying, make sure you have all your supplies. Make sure if you ever do have to evacuate, you know where to go. Get all that stuff out of the way now and then watch everyone else panic while you can sit back and watch a sports game or something. Don't worry about it. But at the end of the day, I wouldn't worry about Aaron all too much. It's going to be an interesting storm to watch, but based on all the data I'm seeing, I think the East Coast will be okay. Close, definitely some wave height enhancements, but I think we're going to be okay with this storm. In the meantime, thank you for joining, and as always, stay safe out there.